So in this session, we'll discuss about work and power, how we define a work done, what is the meaning of work done. When force applied on the object and it can move the object to certain distance, we call that as a work done. Example, on the horizontal surface, we apply a force F, which is same as the direction of same horizontal force is there, and that move the object to a distance d. So if we want to calculate a work done, we know what is the definition or meaning of work done, that is force multiplied by distance. So in this example, the work done will be equal to F into D. But what will happen if the object is making, or if the force is making certain angle with x-axis? So that time we have to resolve the force into the component. So if we are applying a force F and that is making angle theta with the x-axis, so this F will have two components. The one which is, there's a one component that is with an angle and the other component is against the angle. So component which is with an angle, that is equals to F cos theta, and against the angle will be F sin theta. So if you want to calculate a work done, if we move this object to a distance d, because in this example the work done, the the component of the force which is responsible for this movement, the distance g, that is F cos theta. So when we calculate the work done, in this example the work done will be equal to F cos theta multiplied by d. Is it clear? The first two examples, the first one is when we are doing a work done on the both examples, we are doing a work done on the horizontal surface, but the first one, the force is horizontal, the second one, force is making certain angle with x-axis. So there will be a component of the force and we'll always take a component which is responsible for the distance. Now, how to calculate a work done on the inclined surface? So if you want to calculate a work done on inclined surface, there are different ways you can calculate. So this is an inclined surface. A surface is making certain angle. Weight of the object on the inclined surface is acting down. The normal contact force from the surface acting on the object, that is upward, we can denote by letter R. And the inclined surface is having angle theta. So when we take the axis, parallel to the inclined surface, so angle of the inclined surface is the same as the angle of the weight. So this weight now will have two components. The component of the weight which is with an angle, that is W cos theta, and the component of the weight which is against the angle, that is W sin theta. So W cos theta and W sin theta are the two components of the weight which are acting on this object, the two forces. So if we want to calculate a work done in movement of this object, to move this object, if we know the distance, like we know the length of the inclined surface, say the length of the inclined surface is denoted by S. So for how to calculate a work done, if we know the length of the inclined surface, in that case the work done will be equal to, because the W sine theta is a component which is in the same direction as a distance, so the work done will be equal to W sine theta multiplied by S. But if we know the height, like example, if we don't know the distance, if we don't know this distance in the question, if height is given, then how to calculate a work done? If you try to calculate a work done, so in that case, the work done, which force is there in the direction of the height in the same plane, that is weight. So in that case, the work done will be equal to weight multiplied by height. So W into H. But the answer of W into H will be same as answer of W sine theta into S. Both will have the same answers. It will not make difference to the final answer. But it depends on the question which distance is given to you. So if height is given, then weight multiplied by the height, you means, because weight is a force and height is a distance, you will get the work done. If angle, the component of the weight is given, or the length of the inclined surface is given, in that case it will be W sine theta multiplied by the length of this inclined surface, and both cases will get the same answer. So what it shows, both cases, if we get the same answer, it means the work done does not depends on the root. So work done does not depend on the route or the path which we follow. It depends on the starting position and the final position. Is it clear? The concept of the work done on inclined surface? Anyone having a doubt till this point, that the work done on the inclined surface when object is being dragged on the surface or object is being lifted, it will be same. So if you have two objects, one is moved on the inclined surface and the other object, the same object basically, the second case it is lifted up. So when we calculate a work done, the work done will be useful work done. Useful work done to lift the object from the same level to the same height, that will be same. So example, if there is a mountain which is steeper from one side and we want to calculate a work done, for the same object, say object is weight is 30 Newton, object weight is 30 Newton, and we lift them, we move them to the same height. So when we compare the work done for A with B, it will be same. But how it is same? For A, it appeared that it is a shorter distance. For B, it is appeared that it is a longer distance. So, and work done is force into distance. So it means that it should be different. But when we calculate, because as we know, work done does not depend on the route or the path we follow. So when we calculate a work done, if we know the length here, that is L1, and we know the length, we call that as L2. The work done for A, so force will be W, as we already discussed on the inclined surface, the work done, if we know the length of, that will be W sine theta. So it will be W sine theta, and this is example theta 1, which is greater compared to theta 2. So it will be W sine theta 1 into L1. And what about the work done for B? That is equals to W sine theta 2 into L2. And we know the value of the sine theta increases as the value of theta increase. So if the value of the theta increase, the value of the sine theta will also increase. So basically what happened, this was having the theta 1 is greater than theta 2. So this factor will have a higher value and L1 is smaller. But other case, work done for B, because the theta is smaller, so W sine theta will have a smaller value, but L2 is higher. But the product, because this is the product here, so example, if this value was 10 and this is 1, so 10 multiplied by 1 will get 10. What about this one? Maybe this is 2, but the length is 5. So 2 multiplied by 5, what we get, will also get 10. So both cases, the work done will be same. The components of the weight are different. The length which they are moving is different. But the product of the force and the distance is same. That's why the work done is same for object A and B. So work done does not depend on the route or the path which we follow. It depends on the starting position and the final position. Is it clear, the concept of the work done? Anyone having a doubt or a question till this point? So if you want to calculate a work done, which is a product of force and distance, so example, a crane is lifting a load of 1000 Newton through a height 3 meter. So it will be 1000 is a force and height, the distance is 3. So we'll get 3000 joules. What is the concept of the power? Power is how much work done in a unit time, or we call rate of doing work done. So work done divided by time, we call that as power. So power is refers to rate of doing work. And whenever anything involves rate, means it is with reference to time. So we can say power is equals to work divided by time. So if an object is taking a short time, means it is having more power, or object is doing more work done, it means it is developing more power. But we can also have another formula for power. So power, as we know, work done is force into distance. So power is force into distance divided by time. Or power is equals to, as we know, distance divided by time is speed. So we can say power is a product of force and speed. So what is this? This formula is normally used for engines. But at what condition it is used? When object is moving at a constant speed, we can use this power, you can use this formula to find the power of the engine. Example, if there is a car which is traveling at a constant speed of 30 meter per second. So we have the speed. But what about the force? This force is not the resultant force. It is a force required to maintain a constant speed. It's a driving force which is required to maintain the constant speed. So it's not the force, because when object is moving at a constant speed, resultant force is zero. But what is this force? This is called a driving force, which is required to produce a constant speed. So example, if I say if the friction force is 2 Newton, if the frictional force is 2 Newton, how much should be the driving force? The driving force should be equal to the frictional force because we don't want any resultant force. So the driving force which is needed to maintain a constant speed, that is this value F. So when we want to calculate the power, so the force needed to maintain a constant speed multiplied by the speed, so it will be 60 watts. So this generation of the power by the engine is 60 watts. So this is a formula which we normally use for the engines. Is it clear? The second formula for the power. Then word example, if a lift is a crane is lifting a concrete block which is having a weight of 12,000 Newton through a height of 8 meter in 3 seconds. So what is the power? Power is work divided by time. So work is force into distance. So 12,000 into 8, that is 96,000. Divided by time is 30 seconds. So it will be 3,200 watts. Then efficiency, it's a comparison of the useful energy output divided by total energy input, or the useful power output divided by total power input into 100. So in this example, a weightlifter raises 2000 Newton weight through a vertical height of 2 meter in 8.8 seconds. What is the useful power he developed, or what is the power he developed? So we know power is equals to work divided by time, or power is equals to force into distance divided by time. So force is 2000, distance is 2, and the time is 0.8. So 4000 divided by 0.8, that is equals to 5000 watts. Then a wind turbine generate 54 kilowatt useful power. So that is the useful power, and the total input is 180. So how to get the efficiency? The efficiency is the useful power output, that is 54 kilowatt means 54,000, divided by total power input, that is 180,000, and multiplied by 100. So that matches with option C. So when we compare the work done by the excavator with the lift, it takes 20 seconds. The useful work done is W and the useful power is P. And lift take 30 seconds. So what about the work done? Because work done is independent of the route or the path followed. So if we consider that both are moving to the same level, so both will have the same work done. But what about the power? Lift is taking 30 seconds and this accelerator is taking 20 seconds, and we know the relation between power and time. If a longer time period, it means shorter power, smaller or power. So that's why the work done will be same, but the useful power by the lift will be less than P. Then a 30-watt lamp, a 40-watt lamp wasted 34 joules of energy every second. So that is a lost energy. What is the efficiency? Efficiency is a useful energy or useful power divided by total input power times 100. So 34 is joules per second is wasted, means 34 watt is wasted because it is joules every second. So remaining will be 6 watt will be the useful, input is 40 and multiplied by 100. So it will be 6 divided by 40 multiplied by 100, so it is 15% efficient. Now we'll do some questions related to the topic about the work, energy, and power. Okay. Select the graph that correctly shows the variation of an object kinetic energy with the velocity v. I want everyone to participate. What could be the right answer for this? The hint is the kinetic energy is half mv square or 0.5 mv square. That's a formula for kinetic energy. So what could be the right answer? If you check the formula, it is kinetic energy is equals to 0.5 mv square or half mv square. So how the kinetic energy vary with the velocity? It is proportional with square. It means if the velocity is double, the kinetic energy will increase by 4. If velocity is increased by 3, the kinetic energy will increase by 9. If velocity is changed by 4, the kinetic energy will change by 16, vary with a square. So which shows, this is showing a linear relation, like if the formula for kinetic energy was Ek is equals to 0.5 mv. In that case, the variation will be there directly proportional. It should be A, but it cannot be A, the one which shows the change of speed with kinetic. If speed is double, kinetic energy is 4 times. If speed is triple, the kinetic energy will be 9 times. That's why D is the right answer. Is it clear? Discussion. The variation of the kinetic energy of an object with velocity v. Another question. A block of mass m is placed on the bench and a horizontal force is applied. So there is a block which is having a mass m and the horizontal force is applied. The block accelerate along the bench and travel a distance d. So this block move distance d by the force which we applied. And it reaches the final velocity v. V is the final velocity. What is the work done? So how to calculate the work done? Because in this case, as it travel a distance d horizontally, so work done is force into distance. That's why A will be the right answer. In question 3, a mass of 1.8 kilogram is suspended at the end of a spring which is having original length of 0.04 meter. So originally it was having a length of 0.04. Original length means the length of the spring without any load. But when we attach a load, now it is extended the spring and now 3 times its original length. So means when we extend 3 times the original length means 0.04 times 3. So that is equals to 0.12. The question is, what is work done? So how to know what is the work done? Work done is force into distance. So what is the distance moved by the block? That is 0.12 minus 0.04, that is 0.08. So the distance from the original position is 0.08 meter. And what about the force? The mass is 1.8, but mass is not the force, weight is the force. So to get the weight, it will be 1.8 multiplied by 9.81. That will be the weight times the distance 0.08. So 1.8 multiplied by 9.81 times 0.08. So what is the final answer for this? The final answer for this is 1.41 joules. Okay? Yeah. And then whenever we calculate a work done by the spring, the work done by the spring is equals to average force multiplied by the distance. So the force which we use here, that is not the average force, because what happened, the weight of this object, which is 1.8 times 9.81, that is 17.65 Newton. So this 17.65 Newton is the maximum force which act. But when we attach, like spring was there, which is unstretched, and the moment we attach this 17.65 Newton, so the spring will start to stretch to a new length, which is 0.12 meter. So whenever we apply the force on the spring, so it's not like the force directly reaches 17.65. The force will start from 0 and the maximum value of the force will be 17.65 Newton. So what is the energy stored by the spring? So it's not like a constant force acting. It's an average force which act. That's why this value should be divided by 2. Why divided by 2? Because the force changes from 0 till the maximum. The value of the force started with 0 and the maximum it reaches 17.65 Newton. And force continuously changing until it reaches a maximum value of 17.65. Because it is not a constant force acting, it continuously changes. So we take an average force whenever a force is continuously changing. So what is the average? It will be 0 plus 17.65 divided by 2. So that's why this total energy will not be 1.41, it will be divided by 2. So that is equals to 0.71 joules. Is it clear, this example? So this is happening whenever we have the springs, we attach a load, and if the force is not the constant force, if there is a spring or a string or a wire, the force is not a constant force, even weight is constant. But example, if you have a wire and you attach a load of 5 Newton. So originally the wire was not experiencing any force, but so originally the force was 0 and then you attach a 5 Newton. So it's not like the force directly changes, it was 0 and then turned into 5. No, the force vary, it is 0, then 0.1, 2, 3, 4 until it reaches 5. So that's why whenever we attach load to a spring or a string, we always substitute an average force to calculate a work done. Next, wind turbine is used to generate electricity. When the wind speed is 10 meter per second, the power input into a wind turbine is 3.2 kilowatt. Calculate the mass of air per second, which is turning the turbines. I'll continue this discussion. Less than a minute left, so I'll share another link and continue the discussion.